All right, gentlemen, sorry about the delay. Just got done with my golf tournament, so this is as early as I could post. All right, so oxidation reduction is what we're looking at today. So section 4.4. And so oxidation occurs when an atom or an ion loses electrons. So a substance that's oxidized loses electrons, something that is reduced gains electrons. And they have to, like, oxidation and reduction always occur together. You can't have oxidation without reduction or reduction without oxidation. And one way to remember oxidation and reduction would be Leo says Gre. So Leo and Gre, where lose electron oxidation. Okay, so that's the Leo, and Gre, Ger, gain electron reduction. So that's kind of just a way to kind of memorize it, and I even often have to use that combination to remember myself. So definitely a useful tool. So Leo says Gre, and obviously this says just is kind of an in-between filler. Okay, so an oxidation number. When we determine the oxidation number of something, we assign an oxidation number to each element in a neutral compound, and it's associated with their charge, or kind of to balance out the number. And any type of element, if it's just a pure element, so let's say you have pure gold reacting with something else, so you'd have Au. Well, the oxidation number of just that element would be 0 because it's not combined with anything else. And then the oxidation number of a monatomic ion is the same as its charge. So let's say you had sodium ions, which is always Na plus, right? So therefore the oxidation number of that would be +1. Nonmetals tend to have negative oxidation numbers, so that's, you know, like all of the halogens and nitrogen, oxygen, hydrogen, kind of all of that grouping have negative oxidation numbers, and some are positive, but you're going to have to use other ions or other elements that they're combined with to kind of determine that. Okay, so some have fixed oxidation numbers. So oxygen has an oxidation number of -2 all the time, except for if it is peroxide. So like if you think of hydrogen peroxide, it's H2O2. So in that formula, the oxygen, each individual oxygen would have an O or a -1 charge rather than a -2, because each hydrogen has a +1 charge. So if you have H2O2, then the total charge is balanced to 0 when oxygen in peroxide has just a -1 charge. And hydrogen is -1 when bonded to a metal, but it's always +1 when bonded to a non-metal. So if you have hydrogen bonded with, you know, like let's say barium. Okay, barium is going to be +2, so the hydrogen is going to be H2Ba, or BaH2, I guess, where the hydrogen would have a -1 charge for its oxidation number. But then when it's combined with halogens or, you know, HCl, it's +1. Fluorine, okay, so fluorine, part of the halogens, always has a -1 charge, but always has a minus charge. And the other halogens have an oxidation number of -1 when they are negative. They can occasionally have positive oxidation numbers, and that's most common with oxyanions, and we'll look at some examples of that in class. So the sum of the oxidation numbers in a neutral compound is always 0. So kind of some of the examples that I've said so far, you know, like with the hydrogen peroxide. So H2O2, so you've got +2 from 2 hydrogens, -2 from 2 peroxide oxygens. The total charge of the compound is 0. The sum of oxidation numbers in a polyatomic ion is the charge on the ion. So if an ion, so let's say we're talking about sulfate. Sulfate is SO4 2-, right? Okay, so if we have 4 oxygens and each oxygen has a -2 charge, so that gives all the oxygens to have a total of -8. So then the charge on the sulfur has to be +6, because +6 combined with -8 from the oxygens gives an overall charge of -2, which is what sulfate ions have for a charge. All right, so then when we think about displacement reactions, where like one thing kind of replaces something else in solution, um, we can kind of follow it by looking at what's oxidized and where the electrons go. So in a displacement reaction, ions oxidize an element. The ions then are reduced. So what is it? I'm trying to think of what this example is here. So here you've got magnesium solid. Okay, so that little strip that's in that test tube is a strip of magnesium. And if we go to kind of the larger, and then it's being combined into a solution of hydrochloric acid, HCl. So what happens is the magnesium metal is donating electrons to the hydrogen, and so you get bubbles of hydrogen coming off. And so the magnesium is going from neutral, because it's just the element of magnesium, so it has an oxidation number of 0. It's now going, by donating that electron, so Leo says Ger, so lose electrons, that's oxidation, so the magnesium is being oxidized, and then the hydrogen is gaining electrons, because when it's hydrochloric acid, it's H+. So it gains electrons, so Ger, so gain electrons reduction, so the hydrogen is being reduced to become hydrogen gas, okay, and then you get Mg2+ in solution. So that's kind of where those, with displacement reactions, how that kind of plays out. So another reaction here, you've got copper metal being put in a solution of silver nitrate. Well, the silver is an ion to start with, okay, and the copper is a solid. So the oxidation number of copper in the reactant side is 0 because it's elemental, and the oxidation number of the silver, or of a single silver, is +1. And then when when we get our reaction, we get solid silver precipitating out. So that means that the oxidation number of silver is now 0. So it's gained an electron by going from +1 to 0. So the silver has been reduced. Then the copper has lost 2 electrons, so it's been oxidized. And one thing to note is that it only goes in one direction when we talk about oxidation reduction. It isn't a reversible reaction. So you couldn't take copper ions, okay, dissolved copper, and put in like a piece of silver and see the electrons go the other way. Okay, and this is related to what is called the activity series. And this activity series basically is kind of a hierarchy of what can be reduced and what can be oxidized. And the higher up on the activity series, the more common or the more likely that an atom is going to lose its electrons. And so let's say you have things combined. Well, if one thing is higher on the table, then that's the one that's going to be oxidized, and the thing that's lower is going to be reduced. And so we'll look at that in class as far as how, if you've got an ion and you've got a solid, will it react or will it not? All right, so that's it, and I will see you in class tomorrow.